Alright, so in this video, I'll be talking through pages 13 and 14 in the notes packet. This is where we are talking about graphing lines from point-slope form and standard form. So if you remember back on page 10, we talked about how the one line could be represented with three different equations. Yesterday we talked about slope-intercept form, y equals mx plus b, where m is the slope and this is your y-intercept. But we can also talk about point-slope form and standard form. And so for this specific line, here is your standard form, here is your point-slope form. So let us take each of those in turn, starting with point-slope form. So point-slope form is really helpful when we know the slope and we know one point that it runs through, right? It lets us very quickly write an equation for the line based on just that information there. So sorry, let me redo this. So if we want to graph a line with a slope of -2 that runs through the point 1, 3, well, we can just start by going to the point 1, 3. And then if the slope is -2, we know we want to go down 2 and over 1, or conversely up 2 and left 1. Right? Either way, when the slope is negative, that's when we want to go down from left to right. So in this case, we have a negative slope. And if we want to write an equation for this, well, we're just going to use our slope-intercept formula and plug in the specific values of the point. So we know it goes through some point, x1, y1, where the coordinates show up there, and then the slope is the same slope from slope-intercept form. So in this case, we would write y minus y1, which is 3, is equal to the slope, which is -2, times x minus x1, which is 1. So once again, you have x1, y1 being mapped onto 1, 3, and therefore showing up in our equation like that, keeping the slope the same. And the other thing I want to note is that if we wanted to, say, convert this to y equals mx plus b, it wouldn't be that hard, right? We could do y minus 3, and then distribute to get -2x plus 2, and then add 3 to both sides to get y is equal to -2x plus 5. And that is the slope-intercept form that matches our graph. So we can see that that is kind of, right, we have a rationality check. So you're welcome to do that. If you don't like point-slope form, if you can get the right graph, unless it's specifically asking for point-slope form, you can always just convert it to be slope-intercept form. That works too. All right, so now we have some examples down here where we want to write the equation and draw the graph. So I'll start with the graph. We know we go through -2, 3. We have a slope of -4/5, so I'm going to go over 5 and down 4, and put another point right about there. And then I can connect those like this. And so the equation for that is going to be y is equal to, y minus 3 is equal to -4 over 5, x plus 2. And now you might notice that this is a positive, and that's because our x1 is negative, and we also have a negative in our formula. So again, when we have a minus a negative, that becomes a positive, so that equation would show up like that. On this one here, we have a slope 2 through the point -2, 5. This one, I'll start with the equation, and I'll say it's going to be y is equal to, or y plus 5 is equal to 2 times x plus 2, because now both my x and my y are negative. And so graphically, we're going to start at -2, -5, and then increase with a slope of 2 to get a line that looks like this. All right, and now these ones, we have the equation, and so it wants us to write the slope, name the point that it runs through, and then graph it here. So here, our slope would have to be 1/3, because that's where the m in our formula is. And our x1, y1 is going to be 2, 3. So when we graph this, we go to 2, 3, and we're going to have a slope of 1/3. That's going to look like this. All right. And then if we look at this one, we see that our slope, it's not written there. So we imagine that to be an implied m is equal to -1. And then the point is going to be 2, -2. Again, noting that it's backwards here because we have minus y1. So if y minus y1 is the same as y plus 2, then y1 has to be -2. And we can graph this by going to 2, -2, and graphing a line with a slope of -1. And you might recognize that as the slope, or as the line y equals -x, right, with a slope of -1 running through the origin. And I'll leave it to you to try and convert this to y equals mx plus b, and you'll see that, yep, the 2's here cancel out, and you're just left with y is equal to -x. Okay, so moving on to page 14, this is standard form. And standard form can be a little bit tricky to work with. So that's always written in the form ax plus by equals c, and the convention for standard form is that a, b, and c will all be integers, and a should be positive. So if you want to get it in that form and you have fractions, you just multiply everything by the denominator of the fractions until you've converted them all to be integers. And if a is negative, you just multiply everything by -1. That's just convention, right? The convention for writing standard form is ax plus by equals c, where a, b, and c are integers and a is positive. So one way you can graph this is you can solve it for y, right? You can subtract the ax over and then divide by b, and you will get a slope-intercept form equation. You'll get practice with that on the delta math. But sometimes that will give you, sometimes they'll give you a challenging slope to work with where it might actually be faster to graph it a different way. So that's what I'll show you here. So we know, generally speaking, that our x-intercept is located when y is 0. So it's located at some value x, 0. And our y-intercept is always at some value 0, y. So when we're trying to graph a line, it's important to note that you only need 2 lines, right? Any line is defined by any 2 points on it. If you have 2 points, there's only one line that can connect them. So if we're trying to graph a line, one thing that we can do is we can just try and identify 2 points. Once we've identified 2 points, we can graph the line. And well, what are going to be the 2 easiest points to find? Well, probably the ones where we can set one of our variables to be 0. So if you want to find the x-intercept here, you can set y equal to 0. So it'd be 3x plus 0 is equal to 2. 3x is equal to 2. X is equal to 2/3. And we see that point right here is 2/3, 0. And then the y-intercept, you can find that by setting x equal to 0. So 3 times 0 plus y is equal to 2. And you see that the y-intercept is going to be 2. And we see that represented on our graph 2, 0. So let's see how this could work in practice. So we have 3x plus 7x plus 3y equals -21. If I go to convert that to slope-intercept form, I'm going to end up with a slope of, -7/3. Maybe I don't want that. So instead, let's do the intercepts method. So I'm going to first set x equal to 0. I'll first set y equal to 0 to find the x-intercept, right? So that means 7x plus 3 times 0 is equal to -21, meaning 7x is equal to -21, meaning x is equal to -3, meaning that my x-intercept is going to be located at -3, 0. I can go ahead and graph that point. Now I'm going to find the y-intercept, 0, comma y. It's going to be 7 times 0 plus 3 times y is equal to negative 21. 3y is equal to negative 21, y is equal to negative 7, meaning my y-intercept is going to be located at 0, negative 7. And now that I have 2 points, I know that my line is going to be the line that connects those two. So I can just graph that in there. I apologize, I'm not drawing a very straight line there. But it will look something like that. All right, so go ahead and pause the video, try that for these two here, and then I will go over them. All right, so let's do that now. So for the x-intercept, we're going to set y equal to 0. So again, that's x comma 0, meaning x minus 0 is 1, meaning my x-intercept is going to be at 1, 0, right? Because that implies that x equals 1. And then for my y-intercept, I'm going to set x equal to 0. So that means 0 minus x is equal to 1. Negative y is equal to 1. Y is equal to negative 1, meaning my intercept, 0, comma y, is at 0, comma negative 1. So here's my x-intercept, here's my y-intercept. Here's the graph of that line. And then for this one over here, set the x-intercept to be 0. So if we have x, or set y to 0 to find the x-intercept, then we have 4x is equal to 5, meaning x is equal to 5 over 4, meaning my x-intercept is 5 over 4, 0, which is about there. And then if we do 0, comma y, well, it's going to be 4 times 0 plus y is equal to 5, which means y is equal to 5, meaning my y-intercept is 0, comma 5. All right, and then we can connect that like that. All right, so now go ahead and work on the delta math.